Hi, everybody. Welcome to part two of the introductory unit where we're going to look at the very basic structure of the atom. Okay, we will do a more detailed examination later on in a different module. Now, the word atom means the smallest particle of an element that retains the properties of that element. So, what that really means is that when atoms were first discovered or theorized to exist, people said that atoms cannot be divided anymore. And that was disproved because we found subatomic particles. So we had to find a new definition for an atom. And right now, we are saying that it's the smallest particle of an element, which is a pure substance found in our universe that retains all of the properties of that particular element. Okay, so for example, if you take gold, for instance, gold is an element and gold is made up of atoms of gold, and each atom of gold will retain all the properties of that particular element. Okay, so shininess, color, all of those things come from the structure of that particular atom. Okay, atoms are so very, 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 very small that you can only really see them through the lens of a scanning electron microscope, which is very different from the light microscopes you must have used last year in biology, which depends on light and passing light through some sample to look at it, but you can't do that with atoms, okay? So scanning electron microscopes actually just interact with the charge of an atom, and that's how we can get kind of an idea of what an atom looks like. If you're interested, there is this really very short, very cool little movie called A Boy and His Atom made by IBM. You can look it up on YouTube, and even the making of it is quite interesting how to manipulate individual atoms, and it was quite an achievement when it was done. Okay, now let's talk about the general structure of an atom. So, everything that I'm going to talk about right now is in this particular slide. It's just typed out better so that you can look at it at your ease. Okay, right now I'm just going to draw stuff to explain it to you. So, an atom is generally considered to be spherical in shape. Whenever we've gotten an image from a scanning electron microscope, that's what we've seen, that atoms are spherical. Okay, um, an atom has something called a nucleus. Now, you might be familiar with this terminology from biology last year, right? Where nucleus is the center of all the information in a cell. Now, in an atom, the nucleus is literally the center of the atom. Okay, like if you have a sphere, in the center of that sphere is the nucleus. Okay, so I'm going to draw the particles that are in the nucleus. Now, an atom has three particles that are called subatomic particles that you guys are going to learn about. The first one is called a proton, the second one is a neutron, and the third particle that we are discussing is called an electron. Now, these particles have certain properties that we will be discussing in just a little bit. So, these first two particles, these particles are found in the nucleus. The location is in the nucleus, okay? So, protons will be found in the nucleus. So, let's say I'm going to draw an element that has three protons, okay? The blue is protons. And I'm going to draw four red circles, and those are going to be my neutrons, okay? So I'm going to say protons are blue. I'm just following the color coding in the next image as well, okay? Ooh, neutrons, I'm going to say are red. There we go, neutrons are going to be red, okay? Now, those particles are in the middle of the atom, and together this thing is the nucleus, okay? Oops, a little bit of a scribble issue there. This is the nucleus of the atom. Now, around the nucleus, okay, in different spaces just outside on the edge of the nucleus, you will find it's not the best drawing, but I'll try my best. Okay, you will find, you will find the electrons. So I'm going to use black for the electrons. Okay, and these are going to be my electrons. I'm going to put two. I'm going to put two on the inside. There's a reason for it. You'll learn about that later on. The placement of the electrons. And I'm going to put two on the inside. So two, one on the outer ring and two on the inside ring. Okay. So these are my protons in blue. Protons, which make up the nucleus, and my neutrons. Oh, neutrons. And then I have electrons over there. Okay, so let's talk about the mass of these particles. So we know that there are three particles: protons, neutrons, and electrons. And we know that protons and neutrons make up the nucleus, and that electrons are on the outside of the nucleus. Okay, now protons and neutrons actually have most of the mass of an atom. Okay, electrons weigh almost nothing. Okay, so larger than 99% of the mass of the atom comes from the nucleus. So the nucleus is the heaviest, most dense part of the atom. The electrons are kind of just like floating around and they're almost weightless. Okay, they have a small weight, but they're almost weightless. Okay, so nucleus has larger than 99% of the atom's mass, and electrons are almost weightless. Now, let's talk about another special property of some of these particles, and that is charge. So, I'm talking about electrical charge, okay? So, we know general knowledge that there are positively charged things and there are negatively charged things, okay? Electrical charge can either be positive or negative, okay? Now, one of these particles out of the three subatomic particles is positively charged, and that particle is a proton. And one of these particles is negatively charged, and that particle is an electron. So I am actually going to put plus signs inside my protons to show that they're positively charged, and I'm going to put minus signs inside my electrons to show that they're negatively charged. Okay, now the neutrons actually don't have any charge, which is why they're called neutrons. They are neutral, they have no charge. So I'm just going to fill them in. They have no charge. They're just hanging out, giving mass to the atom. Okay? Now, you'll notice that I drew three protons and three electrons. Now, there's a reason for that. Every single atom of every single element in its basic condition is considered to be electrically neutral. The atom itself, okay? Atoms are atoms are electrically neutral. What that means is, okay, if I have three protons in my nucleus, I'm gonna draw them out here, okay? Here are three plus charges. That means this nucleus has a plus 3 charge, right? Each proton has a plus 1 charge, okay? Each proton has one positive charge, so a plus 1 charge. And each electron has one negative charge, so a minus 1 charge for each electron. So if I have three protons, that gives me a plus 3 charge for the nucleus. And if I have three electrons, that gives me a minus 3 charge for the nucleus. Remember, plus and minus charges, they cancel out and you end up with an electrically neutral atom because each plus is balanced by a minus. Okay, so they cancel each other out. Now you end up with an electrically neutral atom. Even though each individual particle is charged, the overall atom is electrically neutral. Okay, so to recap, there are three subatomic particles. Two of them, protons and neutrons, are in the nucleus and they have larger than 99% of the mass of the atom. The third subatomic particle, electrons, they are on the outside and they are almost weightless. Two of the particles, protons and electrons, have electrical charges. Protons have a plus one charge, electrons have a minus one charge, neutrons have no charge. But because proton number and electron number of protons and number of electrons is equal to each other, the charges cancel each other out and you have an electrically neutral atom. So everything that I just explained is right here in this slide, and when I share Google Slides with you, you can access it. And it's also in this video and you can pause it and look at it whenever. Okay, so this particular video, I'll put this in your Canvas module. So just how small is an atom? I actually would like you to watch that video, so I'm considering it a required video. Okay, now let's look at where you find the information about number of protons for each element, and that's called the periodic table. We're just doing a quick look at the periodic table, okay, right now. So here's the periodic table. These are all of the elements that have been discovered in our universe. Some of them are missing, but it's not a big deal because we're never going to use some of these empty boxes anyway. Okay, some of these actually have been discovered since this periodic table was made. So um, look at this table. It looks like a complicated table, right? There's so much information going on, but you're going to learn how to read it in a separate module. But I'm just going to show you the information that is contained within a singular box on the periodic table. How do you read it? Okay, there are these patterns and trends all over this thing that we are going to examine later on. So let's look at this element, carbon, because it makes up everything, including us. We're going to look at the element of carbon and some information about it. Okay, so carbon is sixth on the periodic table. You'll notice 1, 2, 3, 4, 5, 6. Okay, on the periodic table, and here is that image just blown up. The information is not in the exact same order, but that doesn't matter. As long as the information is in the box, doesn't matter which order it's in. Okay, so element name is right here on the top. That tells you what element it is, and related to that is the element symbol. Okay, carbon is just denoted by the letter C. Okay, and carbon also within the box has this number 6, which tells us the placement of carbon in the periodic table. It's in the sixth location on the periodic table. But this placement also tells us how many protons carbon has. So this location is called the atomic number, and it tells us that carbon has 6 protons in its nucleus. So the atomic number is the number of protons in the nucleus of an atom. But remember, that any atom is electrically neutral. So if you know the number of protons, that means you already also automatically know the number of electrons because they have to be balanced out, they are equal. So the atomic number tells us the number of protons or the number of electrons, or is important. It's not and, it's or. Number of protons or the number of electrons in an electrically neutral atom. Okay, so that's the first number. This is a whole number right here. Okay, now the second number, it's the number with decimals. You'll notice that most of the boxes in the periodic table has this number that's a larger number and it has decimals accompanying it. This is called the mass number. Okay, the mass number is actually made up of the number of protons plus, so and the number of neutrons, not or, and the number of neutrons. Okay, that means the sum of protons and neutrons gives you the mass number. Now, the mass number usually has decimals because it's actually an average number of many measurements. But you know we can't have little pieces of particles, so we must first round this to a whole number and then we can do some math with it. Okay, when I say math, I just mean subtraction. So if we know the number of protons, because we know the atomic number is the number of protons, and we have the mass number, which is the sum of protons and neutrons. That means you can figure out the number of neutrons in the nucleus of an atom, right? So look at the mass number here, it's 12.01. If we round that to a whole number, it's 12. I know the number of protons because carbon's atomic number is 6. And my question is, what is the number of neutrons? You can just subtract the number of protons from the mass number to give us the number of neutrons, which is 6. Okay, now you might be like, oh, it's half and half, so 12 must be 6 protons, 6 neutrons. Yes, it is, but that's just for this particular element. Okay, not all elements have the same number of protons as the number of neutrons. For example, lithium, which is the element I actually drew in our picture. Lithium has 3 protons. See, it has the atomic number of 3. And if it has 3 protons, then it's lithium. Lithium is the only one that has 3 protons. If I add a 4th proton to this, I change the identity of the element. That's something that you should remember really clearly. Protons hold the identity of the element, okay? Lithium will always have 3 protons. So, look, it has 3 protons and it has 4 neutrons. Now, if you look at the mass number of lithium, it's 6.941. So, the mass number of lithium rounded to the nearest whole number is 7, right? And if the 7 is made up of the sum of protons and neutrons, and if you know that the number of protons is 3, because the atomic number tells you that the number of protons is 3, that means 7 minus the number of protons. So 7 minus the mass number minus the number of protons is 4. That's the number of neutrons. Okay, so that's what I drew. I drew 3 protons, 4 neutrons, and 3 electrons. So lithium has 3 protons, 4 neutrons, and 3 electrons. 3 plus 4 gives you a 7 mass number. Okay, the mass of the nucleus is 7. All right, now please go and complete the atomic structure assignment on Canvas.